Now we're going to have a look at example 16, and this one is about kinematics. Okay, we're talking about linear motion, so particles moving in a straight line. And here we have the displacement x of a particle after t seconds is given by the equation x equals 4 sine of 2t plus 3. And they're asking us to derive an expression for the velocity v of the particle. Now we need to remember that velocity is the derivative of displacement. So let's have a look. If x is 4 sine of 2t plus 3, we always need to acknowledge that velocity is the derivative of displacement with respect to time. And we also need to say which rule we're using. So by the chain rule, and we have that v is equal to, now we've got a chain rule here because we have a 2t as our inside function. So we have our derivative of our outside function, which will be 4 cos of 2t, and we then have to multiply it by the derivative of our inside function, which is the derivative of 2t, so multiplied by 2, and our derivative of our constant 3 is just going to be equal to 0, and so we have 8 cos of 2t. Alright, B says determine the time at which the particle is first at rest and its position at this time. So its position, we're talking about where it's located, and we want to know when it's first at rest. Now if we have a look at the way this thing is moving, we will see that it's a sinusoidal function, which means that it might be a pendulum or something like that that's moving away from the origin, coming back, then moving away in the other direction. So we're going to have various times when our velocity is equal to 0. So let's have a look. So at rest means when our velocity is equal to 0. So we can say 8 cos of 2t must equal 0. Okay, and we can divide both sides by 8 because that 8's not going to make a difference. And now we need to remember our trig rules. So we know that cos of theta equals 0 when theta is pi on 2. Remember, cos follows the x-axis, so it will be equal to 0 on our y-axis. Pi on 2, 3 pi on 2, etc., etc. So in this case, our theta is equal to 2t, so therefore 2t must be equal to pi on 2, 3 pi on 2, etc., etc. So therefore, when t is equal to pi on 4, 3 pi on 4, etc. So therefore, it's first at rest when t is pi on 4 seconds, and you could approximate that to 0.79 seconds, but tech-free, you would leave it as pi on 4 seconds. Now, the second part of it is saying what is its position at this time. So we're looking for x of pi on 4, and that's going to be, remember, x is our displacement function, so that's going to be 4 sine of 2 times pi on 4 plus 3, and that's 4 sine of pi on 2 plus 3, and obviously sine of pi on 2 is just 1, so we have 4 times 1 plus 3, and that's going to be a positive 7. Now, remember that we need to interpret the sign of our function, so therefore, when t is pi on 4 seconds, the particle is 7 meters to the right. of the origin. Okay, now derive an expression for acceleration and its initial acceleration. All right, so now we need to say, well, we know that acceleration is the derivative of our velocity with respect to time. Again, we need to say by the chain rule. And our acceleration is then going to be a derivative of 8 cos of 2t. So again, we're going to have negative 8 sine of 2t multiplied by 2, and that's going to be negative 16 sine of 2t. And to find our initial acceleration, we want when time equals 0, and when we put t equals 0, we get a equals 0. So our initial acceleration is 0 meters per second squared.